Welcome back to my channel, students. In this video, we are going to learn about the river and swimmer problem. Here we don't have any particular theory about this river and swimmer problem, or sometimes we call it as the river and boat problem, but it is a simple application of triangular law of acceleration. In previous video, we have learned that velocity of a body relative to another body is written as VA bar minus VB bar. And also I told you in this one, VA means what? It is the velocity of A with respect to ground. Okay. And what is VB? Velocity of B A with respect to ground. Here again, an invisible G is attached with the A and as well as the B. That means what? We are taking the frame as the ground and we related the velocities VA and as well as the VB. The same principle we apply when we are doing the river and swimmer problem as well as river and boat problem. Here, say is a river. Okay, students, it has the width of D. This river has a width of D. Okay, allocate the 2 points here. It is one and is the other. The same way. I'm joining the two. Okay, the two have been joined in such way. And the river, this one. The river is flowing with the speed of VR. Means what? The velocity of the river with respect to ground. Here we are taking the ground reference. The velocity of the river with respect to ground. In the same way, just imagine a person jumped into the river. I am showing here. Okay. Making an angle of theta with the ground. Okay, this is theta. And he jumped into the river and he is swimming with a velocity of VSR. Okay. We know the velocity of the swimmer related to river. S means swimmer and R is the river. And we have the velocity of the river with respect to the ground. And we call back the formula. What we did in triangle law. VAB is equal to VA means what? Invisibly the G is attached with this and VB. Okay? Understand? The same can be written here also. Velocity of swimmer with respect to river, relative to river, is equal to velocity of swimmer minus velocity of river. Okay, students, here in this one, velocity of the swimmer relative to ground. Here, do remember, velocity of the swimmer relative to ground and velocity of the river related to the ground. Understanding, students? Velocity of the river relative to ground. Okay. Here, the theory which is involved in this river and swimmer problem, I will call river and boat problem. Here I am taking it as river with two T's because I am calling it as river swimmer problem. And I told you it is a shear application of what we learned? Triangular law of vector H. It is, students. Once again I tell you, this is the river which has a width of D and a swimmer is swimming in the river with a velocity of V bar SR. Means what? Velocity of swimmer relative to river, and river is flowing with a speed of VR. Okay, students, I'm moving this one. Okay, and representing the speed of the river with VR, that is relative to the ground. The general equation is what? VSR is equal to Vs minus VR. Velocity of the swimmer relative to ground and velocity of the river relative to ground. Okay? So these are, we are taking the frame and writing it as x-axis, and automatically this thing will be y, isn't it? Okay, students? Okay, write it as y. Okay, students. And also I am writing the unit vectors. It is the J bar and it is I bar. Okay? J bar and as well as the I bar. Now what I am going to do? Here if you watch it carefully, we have the velocity of the swimmer relative to river and also velocity of the river relative to ground. But we don't have any velocity, okay, which is Vs bar. That means velocity of the swimmer relative to river. Now we are taking the help of triangular law of vector addition, or you can use the parallelogram law of vector addition. It is the one side and it is the another. I am transposing this vector. Okay, students, I am transposing the vector Vs bar. Okay, as shown here. Okay, students, it is the same Vs R. Okay, students, I am transposing the velocity vector. It is here. It is the velocity vector, isn't it? VR bar to this point. Okay. It is VR bar. It is VR. We are adding the two. Okay, by using the triangle. Here we get the resultant of the two. I'm calling it as Vs bar. Okay, students? Understand it? I resolve the velocity into what is it? VSR. By using the VSR, I am trying to find out velocity of the swimmer related to the run with respect to the velocity of the river with respect to the. Here, this equation can be further written as Vs bar, okay, is equal to VSR plus VR. Okay, students? To get that, what I am doing here? I am resolving this, okay, VSR into rectangular components. Automatically, it is equal to VSR cos theta, and this component, this one, is equal to VSR sin theta. Remember, we have learnt about the resolution of the vectors in previous class. Even though I am showing it, if it is the, okay, VSR, we are resolving along horizontal, it is VSR sin theta, and it is VSR cos theta. Here we got by using what sin theta is equal to opposite by hypotenuse, it is opposite, and hypotenuse, it is sin theta. Opposite we have to find y by hypotenuse, VSR, that is y is equal to VSR sin theta. Opposite we call that Vy. Okay, students? That is velocity along the axis. Similarly, cos theta is equal to adjacent by hypotenuse. Okay, x is equal to VSR cos theta. We took the same notation here. Okay, that's why we resolve into VSR cos theta and as well as VSR sin theta. I hope you understood. That means what? The velocity of the swimmer along x-axis. Here I am writing velocity of swimmer along x-axis. I am writing it as Vx. Here VSR cos theta. Okay. Similarly, velocity of swimmer along y-axis. Okay, say it as V1 is equal to VSR sin theta. This one. And here the velocity. Okay, students. Here VSR cos theta and VSR sin theta. Here we will find velocity of swimmer is equal to VSR can be written as what? It is sum of the two vectors, isn't it? VSR cos theta I cap plus VSR sin theta into j cap plus VR. We have the relation. Okay, students? In this way, we can find the velocity of the swimmer along the x-axis and as well as the y-axis. Right now, we are going to find the time taken to reach the other bank. Okay? Time taken to reach the other bank. Okay, students, we are going to find the time taken to reach the other bank. As you know that velocity is distance by time. Here, which velocity is? Velocity is that it is moving in this way. Means what? VSR sine theta is equal to displacement. What we have? D upon time. That is T is equal to what we have? D by VSR sine theta. Already we got velocity of the swimmer, okay, with respect to ground, and time to reach the other bank. Okay, students? Then after, we have to find the drift. Okay, students? Here actually he is swimming along. Okay? Okay, students? And maybe reach other position of the river. Maybe he will reach the other position of the river, not exactly opposite but somewhere. That distance is known as the drift. The distance. And this distance is along horizontal. That means we have to take the velocity of the swimmer, okay, along the horizontal, added with the velocity of the river. When he is swimming, not only he experiences, okay, the velocity of the river on him. So we have to take drift can be written as it is displacement. Displacement x is equal to velocity multiplied with the time. The drift, you can write it as x is equal to, what is x? The drift and velocity. Velocity along the horizontal. That is, we have to write it as VSR. Means what? VSR cos theta added up the velocity of the river multiplied with the time. Time we have d by VSR sine theta. It is the equation for the drift. Okay, students? In this way, we can calculate the drift and as well as the velocity of the swimmer. And the most important thing here is minimum time needed to reach the other side. I hope you understood this equation. Okay? Then after we will find the minimum time. When the time will be minimum. See the equation. Time to reach the opposite bank is equal to T. T is equal to D by VSR sine theta. Isn't it, students? Minimum time means what? If the theta is 90 degree, okay, minimum time is possible when theta is 90 degree. Therefore, this equation can be rewritten as T by D into VSR sine theta. That is D by VSR. Okay, students. It is the needed equation. I hope you understood the river and swimmer problem in right way. And I already told you it is also known as river and boat problem. I hope you understood the concept which is behind this. It is nothing but triangular law of vector addition. If you have the good basics about it. I mean, the concepts about the triangular graph. It will be easy for you. Thank you for watching my video.